Hello, I am Seema and welcome to part 39 of the chapter Equilibrium. In this video, I'm going to tell you about the hydrolysis of salts and the effect of the hydrolysis of salts on the pH of their solutions. Do you know a salt is formed by the combination of an acid and a base? When an acid and a base react with each other, they result in the formation of salt and water. And this reaction is known as the neutralization reaction. This is something that you've studied in class 10 also. Now, when you have a salt and you dissolve it in water, what happens? The salt consists of a cation, that is the positively charged ion, and the negatively charged ion. And since it is ionic in nature, when you put it in water, which is a polar solvent, the salt dissociates, the ions of the salt, they dissociate, or the salt breaks into the positive cation and the negative anion. And when this happens, when it dissociates into the cation and the anion, another thing happens. The water molecule, which is polar in nature, has H positive and OH negative. It can also dissociate into H positive and OH negative. But what happens when you have a strong acid and a strong base which reacted to result in the formation of a salt? The salt that is formed has got a strong cation and a strong anion. And the strong cation and the strong anion prefer to stay separate when they are in water. And when these strong cations or strong anions go into water, they just get hydrated. We call it hydration. What is hydration? Let us say you have B positive ion. Let us say that the B positive ion has entered the solution. Now, the water molecule, which has H positive and O negative, the two H, the hydrogens are positive in comparison and the oxygens are negative. So what do you think would point itself towards B positive? A positive ion in solution, oxygen is the negative part, so you will have what? Oxygen of water and hydrogens on the outside. The oxygens start pointing towards the B positive, which is positive because the oxygen has the negative charge. And such a complex that is formed, it is known as a hydration complex. And the ion is supposed to be hydrated in water. So this is known as hydration. If on the other hand we had the cation, that is A negative here, if it was the anion A negative, what would have happened? Now negative cannot attract the negative, therefore for the negative ion in the center, it would have been the hydrogens which would point towards the ion and the oxygen would point outwards, resulting again in a hydration complex but with a different orientation. Since A is negative and H is positive, the hydrogens in this case of water molecule point towards A and the oxygens of the water molecules, they point outwards. So the hydrogens are here and the oxygen is towards the outside, thus forming another complex which is also a hydration complex. Now, this is what happens when you have a cation and an anion which are strong. Hydration occurs. But if you have a salt that has been formed from either a weak acid or a weak base, or both weak acid and weak base, if either one of these was weak or if both were weak, then the cation and the anion from that weak acid or the weak base, or both the weak acid and the weak base, the cation and the anions would also be weak. So these anions or cations would not prefer to stay in the ionic state because their ionic state is not very strong. So what happens when such weak cations and anions, such a salt is put into water, is dissolved in water, it results in not getting hydrated, but it causes the hydrolysis of water. What does hydrolysis mean? Hydrolysis means, the hydro means water and lysis means breaking down. So it causes the breaking down of the water molecule. And it causes, and how would water molecule break? Because you have an ionic medium, because the water molecule is a polar solvent, and you have an ionic substance which has been dissolved in it, although it may be weak ions. So when the water molecule breaks, it breaks into H positive and OH negative. If the cation is strong, then you would get a hydrated complex of the cation. But if the anion is weak, then that anion would cause the hydrolysis, and the anion would combine, the anion that is A negative would combine with the positive of the water and result in the formation of a species, that is it would result in the formation of the original acid, that is HA, would again be formed, right? So when this happens, when it results in the forming a bond with one of these, the cation or the anion, the other ion, that becomes, that its quantity starts increasing, or it starts exceeding, and that causes a change in the pH of the solution. I think I need to explain this a little better again. So let me follow this stepwise now. You've understood what hydrolysis is. You've understood what hydration is. Hydration is when you have a strong cation and a strong anion, it gets hydrated. That is, the water molecules align themselves around it, resulting in the formation of a hydration complex. But when the cation and anion are weak, it results in the hydrolysis of the water molecule, and the cation and the anion, they combine with the H positive and OH negative to result in the formation of their original acid and base. But if one of them is a weak cation or anion, then only that one will cause hydrolysis, while the other one, the one which is strong, would remain hydrated, causing an imbalance in the H positive and the OH negative, resulting in an effect on the pH. So pH of the solution gets affected by hydrolysis of salts. So pH only gets affected when there is a hydrolysis of the water molecule by the salt, although we call it the hydrolysis of salt because it is the salt which is causing the hydrolysis. So when you have cations of strong bases, that is sodium ion, potassium ion, calcium ion, barium, these are strong cations. The strong cations would get hydrated, they would not hydrolyze. And anions of strong acids, for example, chloride, bromide, nitrate, chlorate, these are also strong. And since they are strong, they would also get hydrated, they would not cause hydrolysis. So they get simply hydrated and do not cause hydrolysis or are not hydrolyzed. We usually use this term in terms of salt, while actually it is the salt that is causing the hydrolysis of water molecule. But we say it is a hydrolyzed salt. So when they only get hydrated, the cations and anions of strong acids and strong bases, they only get hydrated, and therefore they do not affect the pH, and the pH of water is 7, and therefore the pH of that solution also remains 7. It does not cause an effect on pH. However, salts of either weak acids or weak bases, or both weak acid and weak base, they get hydrolyzed, and that affects the pH. How? Now let us take these examples of all three. That is, either only the acid is weak or only the base is weak, and the third case would be both acid and the base are weak. And how does that affect the pH? Let us assume that you have a salt of a weak acid, a salt that was formed by a weak acid, and a strong base. So if the base is strong, it means the cation is strong. If the cation is strong, this is going to get hydrated, but the anion is weak, therefore anion is going to get hydrolyzed. It is going to cause the breaking of water molecule. For example, CH3COONA is a salt that has the two ions CH3COO negative and Na positive. And what would it have been formed from? It would have been formed from sodium hydroxide would have been the base, and acetic acid, which is a weak acid, would have been the acid. So the salt formed is CH3COO-Na. So CH3COO negative is weak while Na positive is strong. So Na positive gets hydrated and CH3COO negative causes hydrolysis. And when it causes hydrolysis, it turns water into H positive and OH negative. Since CH3COO is negative, it combines with hydrogen H positive to form CH3COOH. And what is left of the water molecule? OH negative. OH negative of the water molecule is left. And as we have studied in the previous parts, that the ionic product of water remains constant. And the pH of pure water is 7 because H positive into OH negative is equal to 10 to the power minus 14. We know this. This is the ionic product of water. Kw is equal to 10 to the H positive is 10 to the power minus 7. OH negative is also 10 to the power minus 7. Therefore, the ionic product of water remains 10 to the power minus 14. Even if you add something to it, this number remains constant. The ionic product of water remains constant. The adjustment occurs in order to keep it at 10 to the power minus 14. So, when you added the weak acid and it resulted in the formation of the weak acid CH3COOH. Now the OH negative ion concentration starts increasing because that is left unreacted here. And in the water we already had 10 to the power minus 7 concentration of OH negative, which starts increasing. And when it increases, let us assume it reaches 10 to the power minus 5. Let us assume the concentration of OH negative increases to 10 to the power from 10 to the power minus 7 in neutral water. It increases to 10 to the power minus 5. When it increases, then the ionic product should remain 10 to the power minus 14. Therefore, hydrogen ion concentration should change. In order to calculate hydrogen ion concentration, let us write H positive into the concentration of OH negative should be equal to 10 to the power minus 14. Therefore, from this, when you calculate, H positive would be equal to 10 to the power minus 14 upon 10 to the power minus 5, which would be equal to 10 to the power minus 9. Since the hydrogen ion concentration is 10 to the power minus 9, what would pH be? pH is minus log of hydrogen ion concentration. Therefore, pH will be minus log of 10 to the power minus 9, which is equal to 9. So, what happens as a result of this? When you had a salt of a weak acid and a strong base, it results in the increase in pH value. On the other hand, if we had a salt of a strong acid and a weak base, what would happen? That is our second case. Salt of strong acids and weak bases. For example, you have strong acid is HCl and weak base is ammonium hydroxide. It results in the formation of a salt, ammonium chloride. Now this salt dissociates in water to give you ammonium ion and chloride ion. Ammonium ion and strong acid and weak base. The chloride ion is strong, is really strong, and therefore the chloride ion gets hydrated while the ammonium ion will cause hydrolysis. So ammonium ion gets hydrolyzed and we say ammonium ion plus water. Now since ammonium is positive, it combines with the OH negative of water, thereby making the H positive unreacted, leaving it unreacted, which causes an increase in concentration of H positive ion in the solution. So initially, again, the ionic product of water should remain 10 to the power minus 14. If H positive concentration increases from minus 7 to minus 5 again, now what will happen to the pH? We need not put this value, put 10 to the power minus 5 in the ionic product of water, because all we need to find out pH is the actual concentration of H positive ions, and we have the concentration of H positive ions. What is it? It is now 10 to the power minus 5, and therefore what would the pH of the solution be? It would be minus log of 10 to the power minus 5, which is equal to 5. So pH decreases from 7 of neutral water to 5. So what happens when you add a salt of a strong acid and a weak base in water? It results in the decrease of pH. And what happens when you add a salt of a weak acid and a strong base? It results in the increase of pH. But what happens when you add a salt of a weak acid and a weak base, how does that affect the pH of the solution? Now, however, both of them may be weak, but one of them has to be weaker. How does each one affect? Their pKa and pKb values would decide, or how strong, how weak is the acid, the comparison between their weakness or strength, that will decide the ultimate, the resultant, or the net pH of the solution. So both of them will cause hydrolysis, both of them will change the concentrations of OH negative and H positive, but the resultant of the two, the effect of the two, will give you the pH of the solution. For that we have a formula. Let us first see this. You have a salt of a weak acid, for example acetic acid, and weak base, that is ammonium hydroxide. Now let us say both of these combine to form the salt. The salt would be ammonium acetate. Now when you put that in water, you have acetate, you have ammonium ions and water. The acetate would combine with H positive and the ammonium would combine with OH negative and result in the formation of the two acid and the base, the original acid and the base. Now the degree of hydrolysis, how much of hydrolysis, is independent of the concentration, and the pH depends on the difference between their pKa and pKb values. It depends on whatever is the number of ions that you've added of that salt in it. That is obviously fixed according to the stoichiometric formula of the acid or the of the salt. Therefore, it doesn't depend, the value, the change in pH does not depend on the quantity. It depends on the difference in the strengths of their acidic and basic character. And the formula for that is, the pH to calculate it is, pH is equal to 7 plus half of the pKa value minus pKb value. pKa value of the acid, which in this case is acetic acid, and the pKb value of the base, that is ammonium hydroxide. This is the formula that you use to calculate the value of the pH of the resultant solution. Now, if the difference between these two is positive, if the difference between the pKa and pKb is positive, then the value, the pH, comes out to be greater than 7, and if the difference between the pKa and pKb values is negative, then the value of the pH turns out to be negative, which is understandable because pKa, of the pKa and pKb, you have to find out the pH. How is the pH affected? So if this value is negative, then the value of pH would also go down, and if it is positive, the value of pH would go up. So that is the effect of the addition of salts and the addition of salts to cause hydrolysis and how they affect the pH of a solution. Now I'll do just one salt example in this video before wrapping it up. Give me a moment. Okay, so now this is question 7.25. It is the solved example after the subtopic hydrolysis of salts and the pH of their solutions. The question reads that the pKa of acetic acid and pKb of ammonium hydroxide are 4.76 and 4.75 respectively. You have to calculate the pH of ammonium acetate solution. So you have to look at the acids, the acid and the base. Acetic acid is a weak acid and ammonium hydroxide is a weak base. So what is the formula for such a reaction, for such a solution? The pH of such a solution would be equal to 7 plus half of pKa minus pKb, right? So 7 is the pH of neutral water plus the half of the difference between the pKa and the pKb values of the weak acid and the weak base. So we write this would be equal to 7 plus half of the pKa and pKb values are given to us. The pKa value of the acetic acid is 4.76 and the pKb value is 4.75, right? And half of this 7 so you will get which is equal to 7 plus half of, what is the difference, 4.76 and 0.01. So which would be equal to 7 plus 0. Half of this would be 0.004. 5. So pH of the solution would be equal to 7.005. Right? A very easy question, a very simple question, but the reason why it is important to discuss it right now is that how would you calculate the pH? If one of them was an acid, a strong acid, and a weak base, then the formula would have been different. You would have, if one of the acid and the base were weak, then you would have gone to the ionic product of water and found out the value of the H positive from there and then calculated the pH of the solution. But if both of them are weak acid and weak base, then you use this formula, and from the pKa and pKb values of the weak acid and weak base, you can calculate the pH of the solution. So this was the subtopic. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.